today we got problem 901 medium online stock span. Basically what we do is we get prices of stock and each day we return the span. Span means that counting the current day, what is the number of days the stock price was less than or equal to that price. So if we put 5 in there, right, then it's 5212, but 7 is larger, so span would be 4. So right, this would be 8, so span would be 3 because 1 to 8. So what we need to do looking backwards is find soonest such date that the maximum of those prices is less than or equal to the new price, and we can do that with sec3, where elements of array is time, right? We don't know what time will be, but we can pretend it's 10 to 4, right? And then we update from left to right, and at each point right, we update, we keep maximum sec3, and then we can do logarithmic queries for maximum in some subarray, and we can binary search like from current day backwards, and we can do that in all again, but I don't want to do recursive. Probably don't want to do recursive sec3, maybe I won't. Struct sec3, so we can do that, we can recurse and directly look at the maximums, and we don't have to binary search and do queries, because it will be log squared per query. Basically the foreign memory, but who cares? And this is update, so update pos with value, and we call our inner update, and that means that we start at position 0 in the tree, and it covers interval 0 and -1, and then we want to update pos with val, right? This is what interval we are covering, and maybe you can do it like this, and pos and val. And now if rex minus lx is 1, then we want to do tx is equal to val, and then return, I think, and then int mid is like this. It's max, but who cares? And then we wanna update to x plus 1. So mx, that's the midpoint which we exclude. And now if pos is under max, then we do this update, else update to x plus 2 max rax pos val, and then finally we update the current node. should be, which just gives us the interval, and then we want to find what the latest position. So return query from 0, 0 and LR int query int x int lux int rux int l int r. And now what do we do with this one? So if t of 2 times x plus 1, which is the left node, no, if the right node answer is larger than if the right answer is, yeah, we also want to know what value, so is overval, then we return query 2 times x plus 2. Yeah, I need to also construct the midpoint. So basically we check if the maximum in right tree is larger already, right? We want to go there. So otherwise, if that is not true, we want to pick the one from left side. Okay, now there needs to be some edge casing here, because first we cover the entire array, which we do not want. But technically, do we care? Because either way they're gonna be zeros, so the max theirs will be 0, so we'll never go there. So we just need to check if or right. That means that recurse so far left that it's out. Then we return what? And let's return -1. Not sure this will work, but okay. Let's do a sec3 private sec3 st. Can ignore this guy. St of 1, 2, 3, 4, like that. need this? No, not really. Okay, so we go up to calls, maybe. Not sure, too few arguments. What's up with that? Expected parameter declaration. What's up with that? Just sec3 don't understand. That's so weird. I really don't understand this. What's up with that? That is so weird, bruh. So weird. Apparently I cannot do this. So I need to do like this. Okay, now this will die because there is no base case. So if Rx, so this, yeah, that's stupid. Return this index and then returns the index of what? Of like maximum, maybe, not sure. Then want to return calls minus this, maybe. Okay, so now only the first one doesn't work out. Yeah, so we want max 1 and this. So this should work. No, okay. Sucks. No, so that's index, right? And now if index calls minus 1, return calls, otherwise return, so that maximum is so then we return that means we got the value that is larger, or no? Then return index. Why index minus calls? That doesn't make sense. Calls minus index. should work too. No, it doesn't. That's awesome. So let's print index. No, let's tote index. Am I doing the updates wrong or what? I don't understand this at all, Raf. Because why is this all zeros? Am I not looking for maximum? That doesn't make sense, bro. So first I query this. Let's see. So val is 31. So you're covering this interval, and we want to query this, and our max val is this. Whatever. So we eventually get down to this, and so if we are at this interval, right? So t 2 times x plus 1, so t 2 times x plus 1. Why is that? Okay, so here are we, and then here, so 31 and 41, and if the right value, so if that is larger than value, what? Okay. Okay, let's pretend that the hypothesis that if there is nothing smaller than okay, I don't want emojis. Okay, now this one doesn't work. Yeah, I know what we can do. Vals 10,001. Yeah, probably won't allow me to do that too. So vals I mean, what's the problem? Because you check, at some point you will come to a decision and you see that right is not larger than that. So close minus index. What, now we always return 0? No. It's fair. So then we find 0. Okay, so we return calls minus 0, vals index, price, calls minus index. Index, walls index, oh. Like that, should work. Okay. There is no, okay, let's see. Please work, please work. Let's go. Okay. So I got a login solution with this huge initialization. Now let's see what's optimal. Oh, monotonic stack. Oh, well, that's way easier. Okay, I am just bad at this point. Yeah, I really should have followed it. That's too complicated, bro. Of course, you just store the maximums in increasing way. Whenever you count larger, you destroy the previous ones. Oh my god, bro, what am I cooking with this? That is ridiculous. While st and st minus 1. So its price is smaller than or equal to current price. St push. Self calls 0. So we push price. Self calls. Answer is equal to so answer is equal to self calls plus 1 if not st else it's self stack back. Now it's self calls minus first position, and then we push price self the solution in 2 minutes. On monotonic stack O1. Keep decreasing maximums on a stack, and whenever a new price comes in, first pop all maximums smaller than or equal to the current price. If there is anything left that is the closest value larger than the current price, otherwise current value is the largest, and we can return the number of calls made. The stack we store pairs price day so that we can calculate difference between calculate how many days calculate the span length O1 per query since amortized since each value will be pushed and popped from the stack at most once during so in total we make ON push and pop operations for the N calls. Queries space complexity ON, since in worst case we might need to store also, since we might need to store all prices on the stack if they form a decreasing sequence. Post. Okay, can post. Goodbye.